You know, when you think about a new medicine, you probably picture scientists in lab coats, right? But the real story, it starts somewhere much smaller, with just a single, humble piece of data. And today, we're going to follow that data on its secret journey, all the way from the patient to the pill.
So let's just get right to it. What does it actually take to trust a new medicine? I mean, really trust it. When you get a prescription, what's that thing that makes you confident it's not only going to work, but it's also safe? It's not just about flashy lab results. It all comes down to trust. And that trust, well, it's built piece by piece on a foundation of data. Okay, so let's meet the hero of our story. It could be anything, really. A blood pressure reading, a number from a lab test, just one single observation from one person in a clinical trial. By itself, it's just a number on a screen. But for that number to become a piece of the puzzle that gets a new drug approved, it has to go on this incredible and pretty intense journey.
And that journey kicks off the second it's collected. But here's the thing. Right out of the gate, our little data point slams into its first huge obstacle: privacy. And you got to remember, we're not just talking about a number. We're talking about a piece of a real person's life, their personal story. So what is personal data exactly? Well, according to privacy laws all over the world, it's pretty much any piece of information that can be linked back to a specific person. And I want you to really think about that for a second. This goes way beyond your name or your address. We're talking about your heart rate, your DNA, literally the code that makes you, you. So yeah, protecting this stuff is absolutely crucial.
And this is where things get really interesting. If you look at how the world's two biggest players in research handle this, you see two totally different approaches. In the European Union, it's like they've built this one giant unified shield, one set of rules for everybody, covering all personal data. Simple. But then you look at the United States, and it's more like a patchwork quilt. You've got powerful laws for sure, like HIPAA, but they don't cover every single group doing research. That can leave some gaps, you know?
So how do you bridge that gap for global research? Well, a lot of US companies essentially say, okay, we'll play by the EU's rules. They voluntarily sign up for these 7 safe harbor principles. And this isn't just some boring paperwork, it's a serious pledge. It's a promise that allows data to move safely between continents. It covers everything from, telling patients exactly how their data will be used, all the way to making sure there are real teeth, real enforcement if someone breaks the rules. This is the very first test our little data point has to pass.
Okay, so our data point made it through the privacy checkpoint. Awesome. But now comes the next big question. Is it even right? Is it accurate? This is where it enters the gauntlet. It's like a trial by fire, a process designed to forge that raw, messy information into something rock solid and trustworthy.
I mean, let's be honest, people make typos. It happens all the time, right? Someone might fat finger a number, or a measurement might be just a tiny bit off. Maybe someone just forgot to fill in a box. The point is, raw data is messy. It's imperfect. So before you can trust any of it, it has to go through this intense process of being cleaned, double-checked, and validated. So how does that actually work? Well, it's a pretty cool system. Imagine a computer program is scanning the data and suddenly flags a blood pressure reading that just looks impossible, way too high. That's step 1. A query gets raised. A red flag goes up. Then an alert zips back to the clinic, where a nurse or a doctor has to go back, check the original patient chart, and figure out what happened. They send back a response, and then a data manager on the other end reviews it. If it all checks out, they officially close the query. But, and this is the genius part, every single step is recorded. The wrong number, the query, the correction, who did it, and the exact time it happened. It's all locked in a permanent audit trail. Nothing gets changed without a trace.
So what's the end goal of all this back and forth? What are they aiming for? Well, it's a standard of accuracy that is just mind-bogglingly high. The gold standard in this world is an error rate of less than 0.5%. To put that in perspective, that's like reading a 200-page book and finding fewer than 50 typos. It is an incredibly demanding process for sure, but it's absolutely non-negotiable if you want to build that foundation of trust we've been talking about.
All right. Up until now, we've been focused on the journey of just one single data point. But now I need you to zoom out with me, way out, because a real clinical trial isn't just one data point. It's millions of them. We're talking thousands of patients, hundreds of different hospitals, sometimes all over the globe. To even begin to manage that level of beautiful chaos, you need a master plan. You need a blueprint.
And that blueprint has to deal with this classic project management puzzle, often called the iron triangle. Picture it. You've got 3 points pulling on each other. There's scope, that's all the stuff you need to get done. There's time, your deadline, and there's cost, your budget. And right in the middle of all that tension, That's quality. Here's the catch. You can't change one without affecting the others. If your boss says, we need this done faster, well, something's got to give. Either the scope gets smaller or the cost goes up. If not, quality takes a nosedive. And running a clinical trial is just this constant, high-stakes juggling act between these three.
So what's one of the most powerful tools they have to tame this chaos? It's something called standardization. And honestly, the best way to think about it is like creating a universal language for data. Imagine one clinic in the US measures weight in pounds and another in Germany uses kilograms. You can't just throw those numbers into the same spreadsheet, right? It'd be gibberish. Standardization makes sure everyone is speaking the same language, using the same dictionary, so that a piece of data from Tokyo means the exact same thing as a piece of data from Toronto. And why is that such a game changer? Well, because when all the data speaks the same language, something amazing can happen. It can be shared. And once it's shared, scientists can do incredible things. They can pull the results from a bunch of different studies. They can spot massive trends they would have completely missed on their own. It basically puts scientific discovery into hyperdrive for the benefit of all of us.
Now, this universal language doesn't just magically appear. It's carefully crafted by these big global organizations. They're like the architects of data. You've got groups like CDISC, which stands for the Clinical Data Interchange Standards Consortium. It's their job to draw up the blueprints, to create the very standards that let our one little data point from the beginning of our story join this huge planet-spanning conversation.
So let's recap. Our little data point has survived its first hurdles. It was collected with privacy in mind. It's been scrubbed clean and verified. It's been organized using a global blueprint. And now it's ready for the final act, its most important job of all, helping to deliver the final verdict.
But before anyone can even start crunching the numbers, something really dramatic has to happen. It's called the database lock. And it is exactly what it sounds like. It's the point of no return. It's a formal, final declaration that says, that's it. All the cleaning is done, every question is answered, and from this moment forward, nothing can be changed. The entire database is essentially frozen in time.
And as soon as that lock is on, the final chain of events kicks off. That perfectly clean, frozen dataset is handed over to the statisticians. They're the ones who work their magic, run all the analyses, and create the charts and tables that tell the story. And all of their findings get wrapped up into this enormous report that lands on the desks of regulators, like the FDA in the US.
And just like that, its journey is complete. Our hero, that one single blood pressure reading from the start, has made it. It was protected, it was validated, it was standardized. And now, it takes its place alongside millions of other data points, all of which have gone through the exact same grueling process. Together, they form the solid rock foundation of evidence for a decision that's not only worth billions of dollars, but one that will impact the health and lives of millions of people.
So there you have it, the secret life of clinical trial data. It's a system built on incredibly detailed procedures, all with one goal: integrity. But this whole system is facing a massive new challenge. We're generating an avalanche of new health data every single day, from our smartwatches, from home DNA kits, from our electronic medical records. And so the really big question we have to ask ourselves is, as that mountain of data grows, how are we going to adapt the rulebook to make sure we can still trust it?